Okay, so we're ready to look at base 16 numbers now. And remembering what you learned from base 10, we're going to change this number, 135, base 16, into base 10. We're going to understand what 135 means in base 16. Alright, so the 5 in base 16, we're going to see that that is 5 times 1, because that's the ones column. And the 3 is 3 times 16 because it's in the 15th column. And the 256, the 1 is 1 times 256 because it's in the 256 column. How do we get the column values? Well, same way as we did in base 10, we have 16 to the 0 power. And as you know, anything to the 0 power, other than 0 to the 0 power, anything to the 0 power is correct, 1. So that's our ones column. And 16 to the 1 power, of course, is 16. And then 16 squared, if you use your calculator, you'll see that that is equal to 256. Okay, so that's how we interpret our column values. Of course, we can go further out, 16 cubes and so forth. Now, we need to know one other fact about base 16, and that is that you have to be able to count up to 15 in one place. Just like in base 10, we counted to 9 before we had to use the second place and write 1, 0. Here we have to count up to 15 in one place before we can write 1, 0, right? Which is equal to 16 in base 16. So, clever scientists have devised a method of doing that by adding A through F at the end. Very creative of them to do that. And that gives you 15 different values plus the 0. And here I have written down what those values mean. So, by the way, before we go any further, let me just say that all along, most presenters cheat by just using base 10 numbers without mentioning it to you, but I'm going to be explicit about it. So all these numbers here are base 10 numbers, all these numbers that I'm using, and I'm describing base 16, but I'm using base 10 numbers to do that, just because that's the easiest way to write things down. But I could have written 10 marbles here. I could have drawn a picture of 10 marbles, and that would have been A. And that would have actually been a little bit more organic for you to understand, instead of using a base 16 number to say, oh, well, that's what A is in a base 10 number, to show you that's what A is in base 16. This is what 11 marbles looks like. It's a B. 12 marbles, 13 marbles, 14 marbles, and 15 marbles. So if we had 8 fingers on each hand, this is how we would be writing things today, using more than just 0 through 9. So now we want to convert from base 10 to base 16. So for that to happen, you have to first know what your column values are. So you're going to write down basically these numbers here, 1, 16, and 256. And then let's say we were going to, the second step is select the largest and subtract some multiple of that largest number, and then write the multiplier and repeat. So if we're going to take 123 and convert that to base 16, we will first have to, here in our example, 123, we'll first take the largest number that we can subtract from 123, and that is not 256, right, because that's too big. So we go to the next number, which is 16, and we say what number times 16 will subtract from 123, right? It's got to be large, but not greater than 123. Well, I happen to know that 16 times 8 is 128. And that's going to be too big to subtract from 123. So We bump it down to a 7, and 16 times 7 happens to be 112, which will subtract from 123. We do that subtraction, we get the number 11, which, as you know up top from this chart, here is a B. And so our number is going to be, in base 16, 7B, right? Because we have 7 in the 16s column, which is equal to 112 marbles. And then we have 11 more marbles left over. And that's our base 16 number. Now I want to go back to the previous slide using the base 2 conversion. And you see that I've added some things here to the bottom of it so that you can see how base 2 converts to base 16 so easily. This was our conversion of 123 into base 2, if you recall. And that ended up with these numbers here, 0, 1, 1, 1, 1, 0, 1, 1. Now 0, 1, 1, 1, actually, right, this was the conversion up top here into binary for 123. I rewrote that using different column headings. Here I started from 8 once again. Instead of 128 all the way down to 1, I went from 8, 4, 2, 1, 8, 4, 2, 1. So that I'm taking each of these are called nibbles in computer science. There are 4 bits. The whole thing is a byte. Okay, each nibble in binary converts directly to a number, a digit in base 16. So 0, 1, 1, 1, if you look at it, it's 4 plus 2 plus 1, which equals 7, right? And over here we have 8 plus 2 plus 1, which equals B, or 11, right? 8 plus 2 is 10, plus 1 is 11. But in base 16 we write 11 as a B. Alright, so you can see clearly that base 2 and base 16 are greatly related. Alright, essentially it's this. Decimal numbers are used by humans, and binary numbers are used by computers. But right in the middle of that is base 16, which is used to convert from human to computer or computer to human. So when you are debugging a program or dumping memory in a computer, most programs are going to show you base 16 numbers. And so you want to know base 16, and you want to know binary as the basis for base 16. Thanks for watching. Please leave a comment, and if it was good, as I hope it was, then like me.